All right, welcome to Fundamentals of Geometry Part 2. Now, what we're going to be focusing on in this particular video is we're going to be looking at area and volume in different ways that we apply the formulas. The first thing I want to do is just start right into a word problem that involves trying to do flooring in a house, and we need to figure out what the cost is going to be given the dimensions of each room. So Nancy has just purchased a new house that is in need of new flooring. Use the measurements given on the floor plan as to the right but below, to answer the following questions. She wants to know the cost. First, the cost of ceramic tile is $9.49 per square foot, and this includes the cost of installation. Determine the cost for Nancy to have ceramic tile installed in the kitchen and in both bathrooms. So the cost for installing ceramic tile, we need to look at two things. If we notice what it said, she wants to do this for her kitchen and her two bathrooms. So here's bathroom 1 that I'm seeing in the floor plan. And then we'll have to scroll down. Now we have the kitchen here and the other bathroom here. So now what we want to do is we want to find the area of each room. And if you remember the area of a rectangle, which is basically the shape of each of these rooms, would be length times width. All right, well then that means we want to find the area of the kitchen. That would be 11 times 15, and that will give us the area for that room. And then, actually, we'll just go ahead and do that. So that would be 165. Oops, I just lost my place. Here we are. Feet squared, because that's what everything is always with this particular place. It's all in square feet. We'll say bath 1, and we'll just use the one from right here, which is 7 by 13. And that would be 91 feet squared. Now scroll back up here. I'm going to scroll here. The other bathroom was 9 by 15. So let's go ahead. That would be bath 2. And so that we just said is 9 by 15. And so that would be 135 square feet. Now, we want to get the total so that we can figure out how much it's going to cost all together. So you want to add up all 3 of the square footage for each of those rooms, and we get 391 square feet. Now, we were told at the beginning that the cost is $9.49 for square feet, and we're going to multiply that, there's a decimal there, by 391. And this is going to give us the total cost that it will cost her to tile those particular rooms. And that would be $3,710.59. So that would be our answer for what it would cost her to go ahead and tile those 3 rooms. Now, what's next is going to be looking at more area and volume. And in your modules, I'm just going to show this to you real quick. I have included a geometry formula sheet, which you can use, but it shows you all of the different formulas for various geometric figures. Like this one here, this is called a trapezoid, and you have 2 bases with a trapezoid and then your height. But something I want to indicate is whenever you are finding the area of any of these figures that involve height, it's always the perpendicular height, not the leaning side. Perpendicular height, same with a triangle. So I want you to keep in mind all of that. Down here we have the volume. When we get into volume is when we get into 3-dimensional, because now we're including the height when we're looking at volume. Now, we're going to go ahead and just jump into some problems. Please refer back to your formula sheet for your geometric formulas. If you don't have that, you can go ahead and pause the video and pull that up, because what I'm going to do now is just jump right into area. We're going to start with area. And all we're going to do for this is just do some examples where we're going to apply the area formulas. I just want you to see how you would work through these. For example, this is a parallelogram. Now, if you look at your formula sheet, the formula is A equals base times height. Here's your base, and here's your height, again, perpendicular. So it's not the leaning side. In this case, we would say then area is 14 times 7, which is 98. And area is always in terms of square units. Here's the trapezoid, which I had just shown you on the formula sheet. So if you look on the formula sheet, the first thing I always do is write down my formula. It's going to be 1/2 of the height times base 1 plus your base 2, because remember, there's always 2 bases with a trapezoid. That's going to be 1/2 times 7, and then you're going to add 16 plus 8 to work with the area. All right, I'm going to keep going. So this is going to be 1/2 times 7 times 24. I'm going to keep going. And actually what you're going to do next, and you can do this on your calculator, is you're going to take 24 times 7 and then take half of that. Now, here's a way to look at that on your calculator. If you're using just your basic calculator, you would take 24 times 7, hit enter, and then divide that answer by 2. So you can either times it by 0.5 or take half. In other words, divide it by 2. And you should get 84, and this is in terms of feet, so that would be feet squared. Again, just showing you different ways you're going to apply these formulas, varying the problem. Now, this is a triangle, so if you look at your formula sheet, the area of a triangle is 1/2 base times height. Be very careful. We can do the base. We can see that that would be 20.5. Let me put this in parentheses now. But the height, watch out for the height here. So over here, this is 44 centimeters, but it's the leaning side. Remember, we don't want the leaning side. We want the side that is perpendicular. All right, so that would be this right here. And that would be 138 centimeters. That is what we will use for this problem. Now, from this point, you're just entering in your calculator. So you're taking 138 times 20.5, and then take half of that, or divide by 2. And you should get 1,414.5 centimeters squared. I chose that problem in particular to make sure to keep in mind that sometimes you'll be given the lengths of sides that you don't even need to use. We didn't need to use the 44, and that was okay. All right, area of a circle. So with the area of a circle, you're looking at the formula on your sheet, which is pi r squared. Okay, so with pi r squared, you're going to use the pi key on your scientific calculator. Now, I know with some of the phones, I have the iPhone. When I open up my calculator, if I turn my phone to the side, it will then become a scientific calculator, and there is a pi key on that. But you want a scientific calculator so that you can use that pi key. It will be more accurate than if we just plug in 3.14. Here is your radius. Now, your radius, now be careful, I just want to show you. The diameter of a circle is always all the way across the circle. The radius is half of the diameter. Now, in this case, we were given just the radius, so let me erase that so we don't get confused. So we're going to take pi times the radius squared. Plug that in. So I use the pi key. If you're using 3.14, your answer might be slightly off from mine, but I'm using the pi key on my calculator, and that gives me the exact answer of 1,594.4 miles squared. Now, let's cover this one. This is when you want to find the area of a shaded region. What I'm going to do first is give you steps, okay? Step 1, you want to find the area of the entire figure. Now I call that E. Whatever the figure is, in this case, we have a rectangle. That would be step 1. Step 2, you're going to find the area of the unshaded figure, but I'm going to put or figures because in this case we actually have 2. We have 2 semicircles and a triangle. 3 subtract. So you're going to take the entire area minus the unshaded area or areas, depending on the problem. So now let's go down here. I don't know if you can see that very well, but that should be at the top 30 inches. There we go. All right, first step. We want to find the area of the entire figure. Well, that's a rectangle. That would be area is length times width. The length we're told is all the way up here is 30 inches. And the width would be right here, which it says is 10 inches. It's on both sides, but it's the same. So 30 times 10 is 300 inches squared. That would be the area of the main part of the figure, which is the rectangle. All right, now, just to make some more room, we have 2 figures, the unshaded. So I'm going to call unshaded 1. That would be, let's say, the circle. It doesn't matter which one we start with. We know the formula for the area is pi r squared. And so that would be, now be careful with this, because we were just talking about that in the previous problem. What you're given here, now notice you have 2 semicircles. That is the same thing as a whole circle. So we're just going to find the area of a whole circle. Notice here, we're given the diameter of the circle, which is also the length of the rectangle, as 10. That means the radius is 5. So be very careful that you're looking at the radius and not the diameter. That's going to give me pi times 5 squared. And if you plug that in, you get 78. And again, I'm using the pi key to get the exact. But I get 78.54 inches squared. Then we have another unshaded figure, which is right here, the triangle. Well, let me just put that here. Well, that's going to be 1/2 base times height. All right, well, we know the base because it gave it to us. It's 15. And the height is 10. That means I'm going to take 10 times 15, which is 150, take half of that, and you get 75 inches squared. All right, last step. The area of the shaded region, right, is the area of the entire object, which we found to be 300 inches squared, minus the area of each of the unshaded. Just enter those into your calculator, and we get 146.46 inches squared. That is now the area of the shaded part of the rectangle. All right, those are always a lot. So if you need to pause and go back, you can do that. Next, we're going to jump into volume. If I can get it to open, there we go. Now, for volume, let me just fix that number. That should be a 13.5. I don't know why I didn't copy over. Now we're just looking at volume. And what we're going to do is try to look at the shape, and then we can create or find the volume. Now this is a cone. I always remembered a cone is 1/3 of the area of a cylinder. Not that you have to remember that, but for some reason it's always stuck in my head. The volume of a cone is 1/3 pi r squared h. Okay, well, in this case, that's going to be 1/3, again, your pi key. Ooh, the radius. Now be careful. This is the diameter because it's showing us it's going all the way across. So our radius is 3. And then our height is 13.5. From here, this is just all entering in the calculator. Now, here's what I suggest with a scientific calculator. Take 3 squared, multiply that by 13.5, then multiply that by pi, and then divide that entire answer by 3, and then you will have your volume. Make sure you're practicing this with me so that you can see if you're getting the correct answer. Volume is always in cubic meters or in cubic units instead of squared units. So that's the difference. Area squared, volume is cube. This right here is a sphere. And so if you look on your formula sheet for the volume of a sphere, it's 4/3 pi r cubed. In this particular case, we have, let me just get that. We're going to get our radius ready. This is the diameter, so the radius would be 4. That means I'm going to take 4 cubed. Remember, 4 cubed is the same thing as 4 times 4 times 4. What you would do in this case, if you're using, again, just a simple calculator, take 4 cubed times pi times 4. Then divide the entire answer by 3. That's just one option to use. But you should be getting 268.08 centimeters cubed. All right, let's try one more. This is what we call a cylinder. And the formula for a cylinder, like I said, is very similar to the cone. The cone is just 1/3 of it, but it would be pi r squared h. In this case, we've got pi. Now, we want r squared, and we need our height. The radius is 6 inches. So, I'm sorry, the diameter is 6 inches, so our radius would be 3. And the height is 27. Now you can plug this into your calculator. You would take pi times 3 squared, which is 9, times 27, and I always weight around at the end, so around 2 places. And that would give me 7. Oh, sorry, it was not that. Let's erase that. We're just going to delete everything I just wrote there. That's not the answer. It would be 763, just in case you actually are following along with that, 0.41 inches cubed. I was looking at a different problem that I had done earlier. Okay, now I want to end this with a word problem. Yes, we got to do those word problems. All right, let's look at the question. Now, it says that we have a spherical storage tank with a diameter of 36 feet and is full of water. How many delivery trucks with cylindrical tanks measuring 6 feet in diameter and 10 feet long can be completely filled from the storage tank? Okay, let's talk about what we've got. We have a spherical storage tank that's filled with water. We want to empty that tank by filling it up with cylindrical tanks. And we want to know how many of those tanks would need to be ordered to empty out this tank. All right. Well, let's go ahead and think about this. We're talking about something being filled up, which means we're talking about volume. So the first thing we want to do is find the volume. I'm going to put this as step 1 of the spherical tank. I'll just put sphere to save on writing. The volume of a sphere. So remember we talked about the volume of a sphere is 4/3 pi r cubed. All right. That would be 4/3 times pi and then times our radius. It says here that the diameter is 36 feet. That means the radius, remember, is half. So that would be 18. Now you're going to take 18 cubed times pi times 4 and then divide that entire answer by 3. Again, if you need to slow down to do your calculations, just pause my video and you'll be good. And what you should get, and again, this is me using the pi key because I like to get the exact answers. And then we get 0.02. That is the volume of the sphere that has water. Step 2. Remember that they're going to be emptying out into cylindrical tanks. So what we want to do here is find the volume of a cylinder. And we know that that one is pi r squared h. So I'm going to take pi. Now the radius, did it tell us the radius? Let's see, it told us, 6 feet diameter. So our radius would be 3. And it gave us the height. It says long, but that's also your height. But you have to kind of picture the truck this time as if it's a truck with a tank, it's going to be lengthwise and not sitting straight up. So the length, the long, would be the height. So times 10. Now take 3 squared times 10. That's going to give you 90. And then times pi. And what you should get is, where'd it go? 282.74. And again, this is all in terms of feet. All right, last step. Okay, so the final step. We are going to now figure out how many trucks, right? So we have the volume of the sphere and we have the volume of each cylinder. We need to figure out how many of those trucks we need to empty out the sphere. Well, then that means we're going to take the volume of the sphere. I'll just do it like this and divide it by the volume of the cylinder because that's going to tell us how many trucks we would need. All right, so that means, let me just write out what we have. You're going to divide that. Now what happens is you get something like, it's going to be like 86.4, but we're talking about trucks. So we want to round up to the nearest whole truck. In this case, then that means we would need 87 trucks to empty out that spherical storage tank. All right, that ends our unit for volume and area.